Let's learn about IP version 6 addressing formats and conversions. As you may know, IP version 6 has 128 bits and is written in hexadecimal digits. Here is the conversion table between decimal, binary, and hexadecimal. As you can see, it takes 4 binary bits to represent a hexadecimal. Therefore, each hexadecimal represents 4 bits. Here are the written rules for IP version 6. IP version 6 contains 8 quartets. Each quartet contains 4 hexadecimal digits. IP version 6 long form is represented by 32 hexadecimal digits. Here is an IP version 6 written in the long form. As you can see, it has 8 quartets and each hexadecimal digit represents 4 bits. So a quartet represents 16 bits. Therefore, the 8 quartets of IP version 6 has 128 bits. As you may notice, IP version 6 in the long form is difficult to remember, and it is a lot to type on a command line. Luckily, IP version 6 also defines ways to abbreviate or shorten how you write or type an IP version 6 address. Here are the rules. First, remove the leading zeros. For a quartet of all zeros, write it as a single zero. So in this IP version 6 address, in the first quartet, there is no leading zero, so we just write down. The second and the third quartets are all zeros, so we make them single zero. For the fourth quartet, we remove the leading zero and write down. The fifth, the sixth, and the seventh quartets are all zeros, so we make them single zero. The last quartet, there is no leading zero, so we just write down. After finishing the first step, we need to replace the longest set of 2 or more consecutive quartets of all hex zeros with a double colon. The double colon means 2 or more quartets of all zeros. Now look at the IP version 6 in the first step. We see that there's 2 sets of consecutive quartets of all zeros, set 1 and set 2. Since set 2 is longer, we replace the set 2 with a double colon, which completes the conversion process. And here is the IP version 6 in the short form. And as you can see, the double colon replaces the set 2. It is very easy to expand an IP version 6 from short form to long form. Here are the expanding rules. First, we need to add the leading zeros to each quartet to make it have 4 hex digits. Let's add the leading zeros to each quartet of this IP version 6, which gives us this address. Next, we need to replace the double colon with the set of 2 or more consecutive quartets of all hex 0 to make the IP version 6 contains 8 quartets. We see that the IP version 6 in step 1 have 4 quartets. So to make it 8 quartets, we have to replace the double colon with 4 quartets of all hex 0. And here is the first 3 quartets. Now it comes with the double colons. So let's replace it with 4 quartets of all hex 0 and add the last quartet. And here is a long form of the IP version 6 address. Just like IP version 4, IP version 6 uses the prefix concept for subnetting. IP version 6 uses the prefix length to identify the length of the prefix. IP version 6 prefix length is written as a forward slash followed by a decimal number. The decimal number defines how many bits are used for the subnet. And here is an example. As you can see, this prefix length tells us that it uses 64 bits for prefix. Therefore, this is a prefix. Let's find the prefix for this IP version 6 address. Here are the rules. First, we need to divide the prefix length by 16 to get the quotient and the remainder. As you can see, the prefix length in this case is 72 bits, so the quotient is 4 and the remainder is 8. Step 2 tells us that the quotient is the number of the first consecutive quartets in the address that belong to the prefix. Finish if no remainder. If there is a remainder, it is the next consecutive bits that also belong to the prefix. In our case, the quotient is 4, so these first 4 consecutive quartets belong to the prefix. Since the remainder is 8, so the next 8 bits also belongs to the prefix, which means these two hexadecimal numbers belong to the prefix. Step 3 tells us that the remaining bits are host bits. Set them to 0. Here are the prefix bits, and the remaining bits are host bits and must be set to 0. Step 4 asks us to find the short form of the prefix, and here is the short form of the prefix for the IP version 6 address.